Hey, welcome everyone to my next video on ftrace, where I'll be talking about how to filter for different kind of trace arguments. So in this video, we're continuing to talk about ftrace. As you can see, I am as root. Who am I? Root, and I've cd'd into this folder where all the ftrace API and like the configuration options and everything, like the files and everything, is located. In previous video, I talked about the different kind of tracers, right? That you can see under the available tracers. So if I do cat available tracers, I'm going to see, well, I have a couple of these, and I'm talking about the knob tracer right now, which is just a simple event tracer. Now, my current tracer is, well, obviously NOP. If I wanted to change it, if it were something else, I would say echo NOP to my current tracer, to make it like the NOP tracer. But it is the NOP tracer right now. I already showed you in a previous video how you would trace scheduler events. But let's say you want to filter these events. Like you don't want to get a lot of events. Let's say you only want to see events that relate to the scheduler when scheduling from an idle state into something else. Or let's say you only want to look at the scheduler events that concern the X terminal, like the XORG process, or all the scheduler events that correspond to some other thing, right? So let me show you a sample of an already collected scheduler events. As you can see, so we have like sketch switch events, sketch waking, and we have like the previous command, swapper2 means it was idle, previous priority, previous PID 0, and so on and so forth, okay? So the next com and so on and so forth again. So let's say I'm only interested in the scheduler events when scheduling um, into the idle state. So whenever something on the CPU finishes its um, like processing and the CPU is taken away, but there's no other task for it to execute. So it actually sketch switches into the idle state, right? Now the idle state is characterized by a PID of zero, PID of zero. So in this case, the previous one was zero idle, so the prev PID is zero. But I would be interested in the case where the next PID is zero. So how can I filter on this? This is an argument to this trace point. So let me show you how we would do this. And the reason you would want to do this is you just want to cut down the amount of events because there's just so many events in this trace file. And this actually it's a trace buffer. It's located in the RAM. And what you want to do is you want to record the maximum amount of time, right? Possible. So you want to reduce the number of events as much as possible. Filtering is going to help with that. You want to reduce the clutter because it just makes it easier to study the events when you have filtered them out. Like you're just looking at the ones that you're interested in. So let's just do that. Now, if I show you like under events, the class of scheduler events, there is a filter here, right? Which is going to be a global filter for all these events. But then there are more specific events for sketch switch events. So um, like sketch switch and then filter, right? I have a filter here. And if I cat this, look at the internals, it's just going to be empty. Okay. Well, actually, no, it's not empty. I already had something in it, which is basically telling me only look at the events where they have com equal XOR. So let me just remove that. I'm just gonna echo nothing into it. It's gonna give me an error, but the end result is that it's just gonna the filter is just gonna be empty, right? So what I'm gonna do is I'm going to put my filter and say, well, okay, I'm going to put it in double quotes. That's good practice. And say next PID equal 0, right? This means that the sketch switch events when the next PID is idle. So when you're actually switching into an idle state. I just want to record those, right? And this filter is applied to sketch switch events, right? Okay. So if I do cat the filter, you can see it's here. If this was not here, or there was like an issue with the way I'm specifying the filter, it would give me an error. Like if I said, well, let's say, next PID, something like that, right? Or just say next equals 0, right? It doesn't recognize this, so it's going to say, well, invalid arguments, okay? And then it's going to say like this here, parse error, field not found, right? So, that tells you that it couldn't accept this. So let me go back and kind of change this to the right one, okay? And I have my filter set up. Okay, so I'm going to start tracing. But first, I need to enable the sketch switch event. I just want to enable this guy. Enable, okay? Then I'm going to enable tracing on, tracing on. I'm going to start tracing, and I'm going to look at the trace pipe, which is, as I said, it's going to continuously dump, like I'm just going to consume this buffer. So if you pay attention, like it's moving fast. Let me just stop it, right? See, the next PID is always 0, next PID 0, next PID 0, next PID 0. Let me just blow this up, right? Maybe reduce the size a little bit. Yeah, so you see that, like a lot of the time, like what you can see is all the times that the CPU is switches to idle. And a lot of the times that it was, executing cat, and sometimes it was executing OBS, which is like a video recorder I'm using to record these, and so on and so forth, right? Okay, let's have this running and play around with this a little bit. Okay, so what I'm gonna do is I'm just gonna dump this information, but in its separate window, I'm gonna actually play a little bit more with this. So what I'm gonna do is I'm gonna say, okay, what I'm interested to know is I'm gonna add more filters, right? I'm gonna say echo double quote um, pravcom equal, let's say xorg, right? This is the X terminal, this is the graphical terminal. So whenever the graphical terminal uh, switches to idle state, and next PID equal 0, then put this into event, the filter for this guy, sketch switch, filter. Okay, invalid argument. Well, obviously, because this is a string, I had to put it in a single quote, and there you go. Okay. So, see, it's all prevcom, this. Well, actually, what happened is that I'm actually getting all these other events. Let me just filter them out first. Just have this running again, because these events are probably enabled. So scheduler class of events and enable. Yeah, these are enabled. So I'm just gonna disable everything except for those sketch switch events, and I'm gonna re-enable only sketch switch. Let me just reduce the size for this one a little bit. Okay. Yeah, this is probably better. There you go. Okay, so I'm gonna say sketch switch and only enable this event. So you can see these are only sketch switch events, and it's only prevcom is xorg, right? As you can see here, and then next PID is 0. I hope you can see that, right? So yeah, that's how the filters work. So let me stop this. Okay, and then I'm gonna say echo 0 tracing on. So stop tracing, tracing on, stop tracing. So it's not gonna be tracing anymore. Yeah, there you go. Let's end. Like, nothing more here. Good. So I just showed you how that works. Now, what if you wanted to apply a filter to a bunch of events? So let's say I have all the scheduler events enabled, and so events, sketch, and enable. I want to enable all of these scheduler events, right? And then I want to specify a filter on all of these. Well, what I'm going to do is, well, obviously the arguments for different events are different, but sometimes the arguments would be shared. So whatever filter you specify is going to be matched to all the events in that class that you have enabled. And whichever kind of matches, it's going to apply to that, and it's going to filter that one. So if I say echo um, com equal, let's say what, xorg, okay? This is only going to apply to these. Let's just have this, let me run this, right? It's easier, probably it's better to see it that way. I'm going to start tracing on, start tracing. I'm going to cat the trace pipe for you. So all the scheduler events are going to be dumped to the screen here. And well, this is not usually how we trace, but we try to, like, stop tracing and then look at the file and then copy it over. But just for illustration, I'm doing this so that you can see that the rate of events that are produced kind of becomes lower as I add filters. So I'm going to say echo com equal xorg. Oh my God. And then put this into events sketch. And just hold on a second. Let me see. Think. Yeah, I need to remove the previous filter, by the way. So I'm going to do, let me just show you the filter sketch. So filter. Okay, let me do this. We're just going to say echo nothing into events, sketch switch. Oh, not sketch switch, everything. Filter, right? Yeah, there you go. Now you have everything. And I don't know if you noticed, but I noticed that the rate of events that are produced kind of went up. So what I'm going to do now, I'm just going to say echo com equal xorg, and then send this to events sketch filter. So it's going to only be limited to xorg, right? See, xorg. Yeah. If I say prevcom xorg, right, and put it into the filters, what I'm going to see is that, let me just stop this now. If there is an event with like prevcom, when none of these are, the filter is going to be applied to that. Yeah, so actually sketch switch. I'm looking for a sketch switch event. Yeah. Because we have a lot of the other events. So maybe the best, maybe it was best if I had used the com thing. Okay, so I'm going to define a different filter, which is more frequently applicable. There you go. So I'm going to stop this, and you can see that the sketch switch, okay, um, so what happened is that because I applied this and I applied this, right? This guy applied to the sketch switch event, which is, yeah, there you go, this one. And then when I wrote this kind of controlled some of the other events that had like a com field, right? So, it controlled these events. So you can see that events having com as xorg have been filtered out, or prev com have been filtered out. And that's how this works. Okay. Um, yeah. So this is essentially how this works. And there are various combinations of filters that you can apply, and it's not really all that well documented, so you have to kind of tweak it and try it and see which works for you. But essentially, this is how you would use filters on event arguments. Okay, so let's say now we want to filter for a certain PID. For instance, I'm not interested in the events that happen for like all the system-wide, all the processes and all the kernel. I'm only interested in the events that happen for a certain process. Basically meaning that when the event happened, the task running on the CPU had a certain PID. I'm only interested in that. To do that, it's also possible. It's easy. So let me just first, disable tracing. So I'm just going to tracing on zero. So and then I'm going to say echo um, events, event scheduler. So let's just turn off the filter, and let's turn off the. Let's just disable these guys. Put a 0 into enable. Right. So we're good now. Like if I did, yeah. So yeah. So that's fine. So let's say cat trace pipe. Make sure this is empty. We emptied it. Okay, good. Or I could have done echo this into trace. It would have the same effect. Now, that's done. Okay, so there's a file here. It's called set event PID, right? Set event PID. So set event PID, my cat set event PID, it's going to tell you that, well, there's nothing in there. If I want to trace a certain PID, I need to provide that PID, like put it into this file. Or if it's the list of PID, there's another, I'll put all of that list into this file. Okay, so let's say, I'm interested to trace my VS Code, right? VS Code, PID of code. So this is the PID of code. I can say, well, echo this guy into, or actually it's better to say it like that because I want to append it, right? Set event PID, right? And then if I say cat set event PID, PID, well, I'll see this one. Now, for now, I'm not going to put the rest. Let's just start with this one and see what we get, okay? So now I want to know all the events, let's say, that happen for this one. Well, it's really kind of like it doesn't make sense to have all the events, but let's say a good subset of the events. So I'm gonna echo one into the events. Yeah, well, I could do this and enable all. Yeah, I could go crazy. So I could say enable all events. So if I put a one in here, it's going to enable all the events, but it's going to be only for this PID of my VS Code. This guy here, okay? So Done. Now let's start tracing. Echo 1, tracing on. And I'm just going to dump the trace pipe. There you go. So this is my trace pipe. You can see code is running. It's syscall enter, like sketch switch, and then went from code to next process and so on and so forth, right? Doing a bunch of things, allocated pages of memory, and then system call enter, system call pull. Let me just, yeah, okay. So this guy is what I'm talking about. And let's see if we can do something interesting with this. Uh-huh. Yeah. So yeah, I'm doing some scrolling here. Let's say I'm searching for a file, or actually just gonna open a file, right? Yeah, should have some effect over here, like a system call maybe has to be executed and so on and so forth. So you see the system calls, so yeah, this is basically I'm covering all the events that are triggered by VS Code. But actually, this is only one of the PIDs. So let me stop this for now and echo 0 intro tracing on, empty the trace buffer. Okay, now, so PID of code, right? So what I'm going to do is I'm going to say all of that into set event PID cat set event, whoops, PID, and there you go. Voila, all of these guys. Because PID of code, it's basically all of these guys are now here. If I wanted to add them one by one, I would have to, say echo, let's say this guy, right, into, set event PID. But then for the rest, I had to put this sign because this means append to the end. If I had put it like this, it would overwrite the things I already have there. But anyways, I don't have to worry about that because now I have it all here. Okay. And then I'm going to start tracing, echo 1 into tracing on, and I'm going to cat the trace pipe. There you go. So actually a lot more events here happening. This is for all the threads and processes that are related to code, VS Code. If I, see, it goes crazy when I actually have this one open here, right? Open a file, whatnot. Okay. Now it kind of calmed down because it's in the background. Anyway, so that's how you would follow a certain PID. Now, one important thing to note is that we have, okay, so let me just turn off tracing on and then echo 0 and turn off this crazy mode of uh, tracing everything. And then echo nothing into set event PID. Okay, good. So now also clear the trace buffer. Okay, yeah. So we learned how to trace a certain PID. But what if this PID forks, right? So I kind of collected a bunch of PIDs and put it in there, but what if some process forks and I want to follow that fork process? And fork is basically when a process creates another process or another thread, and kind of that one, the new one, kind of the child continues on its own, right? We call this fork. How am I supposed to follow that? Like maybe I don't want to follow it, but like, and then that's fine. But if I do want to follow it, then I can't just go in the middle and kind of add the PID for that one into here because that's inconvenient and I've already lost some time, right? So there's an option so there's a file called trace options, and it kind of changes the behavior of your tracing. So these are all the trace options that you have currently configured. And there's something called event fork, right? And then you can actually see this in the documentation as well. So, trace options, searching for this, and you can see that, okay, so there's got to be some, yeah. So trace options, these are all the options that you have, right? So this explains what is print parent, what is symbol offset, what is symbol address, verbose, and whatnot. And then actually somewhere around event fork is basically tells you when you set this to event fork, uh, if the task creates a PID, it creates a new thread and forks, um, then the PID, the PID, and in a sense, like when I'm talking about the PID, I mean the TID, PID, they're all the same, right? In this scope. Um, so the PID, the PID for that thread is going to get added to this set event PID as well, right? So it's basically going to follow that as well. So if I have a thread set here, right, a PID set here, and I want to follow the threads that are forked out of this as well, then I would have to say, like, set the uh, trace options to event fork. Right now, it's at no event fork. So it means that event fork is disabled, right? Okay, so how am I supposed to do that? Well, it's easy. Just put it, echo it here. Echo, and here you just have to do a simple echo. Like you don't have to worry about whether it's going to be like an annex, appending, or just writing, right? It can be like this, and you're going to say event fork. Well, actually, sorry, event echo. Sorry about that. Event fork into trace options. And if I do cat trace options, what I'm going to have now is that event fork. See, compare that to no event fork, right? Now it's an event fork. So if my process forks, I'm going to be able to trace that as well. Now, again, this is only and only if we have set this guy. If we have not set this guy, this would be irrelevant. Okay, and there are a bunch of other options as well that, we'll get to them in some other videos. And then there's another filtering mechanism. It's basically a set event no trace PID. Let's say instead of wanting to only trace a whitelist of PIDs, you do not want to trace a blacklist of PIDs. You would put them here, right? So let's say I want to trace everything except some bunch of noise processes, right? I'll put them here. And you can have both this guy and this guy, right? So you can say, okay, trace these guys and then don't trace these guys. Well, I'm not saying it makes sense, but you could have it. And then the no trace one, as far as I know, always supersedes to, like, if something by mistake happens to be both in no trace and the event PID, uh, it will not be traced. Okay. So that's what I was going to talk about, the filtering. Now you can think of so many different things that you could do with filtering. Let's say I want to filter all the disk write um, events, all the events related to disk write, for instance. You would say, okay, so it's in the block device events. So let's just take a look at them. Events, block, and block RQ issue or block RQ insert. Let's go for this one. And then let's look at the format. And this is basically like this, which is essentially read, write. That this tells you if it's a read or write, and then um, the number of bytes, and so on and so forth. So basically, what you're going to be doing is that the RWBS field, you're going to be looking at the RWBS field. Um, it's it's 8 bytes, right? And then you're going to define a filter there. So let's just do this for fun. Uh, First off, I just want to trace this like without a filter. I'm just going to say echo 1 and 2 events block, and I just want to limit it to block request insert insert a block request, and I'm just going to say enable, right? And then echo 1 and 2 tracing on, and then I'm just going to dump the trace pipe without like online. Okay, so you see this is the device number, and this is write, this is W, this is a write thing, right? uh and then sometimes, well, we should have some sort of a read somehow. uh Once in a while it should pop up, but essentially, it basically tells you that, yeah, okay, so I need to search for this, right? So what I'm going to do is, oops, I needed the formats. Yeah, this guy. I'm going to look at the RWBS. I'm going to define a filter. Let me just put this on the side, and actually, let me just, yeah, let's just dump the trace pipe. So it's RA. Read is RA. Okay. Read is RA. um, and what I'm going to do is I'm going to say RA for this one, and then RA for issue, both issue and both insert. And I'm going to say also for complete. That's when it is completed. And I'm also going to enable the complete events. So essentially, I'm going to be tracking when a read event is issued to the driver, it's inserted in the driver queue, and it's completed. And I should see this when I read stuff. Well, this was already cached, but maybe if I scroll down a little bit, oh, this was already cached. This one, no, not here. Let's go somewhere else. Yep, this one. There you go. It's a new file I opened. It wasn't cached. And again, this guy. Yep, there you go. So you see, it says that, yeah, let's blow this up. What it's telling me is that, hey, you actually GVM, that was the process. And that process issued a block request to the disk, this much for 96 max kilobytes, and it got completed, right? And then this is how much time it took, right, from here to here, and also this other second one, right? That's all of it. So I hope you enjoyed this video and kind of gave you maybe a little bit kind of like a superpowers in terms of how to use tracing effectively without overwhelming yourself with a lot of data. Stay tuned for your next videos explaining about function tracing, and I hope to see you then. Bye bye.